Okay, number 9. The diagram shows a crane PQR that carries a flat box W. PQ is vertical and the floor PM is horizontal. Given that PQ is 8.2, QR is 12.3, and angle PQR is 100 degrees and RW is 7.8, calculate PR, the size of angle PRQ, and the height of W above the floor PM. And they drew the picture all for you, so it's almost like you don't even have to read it. But they might have some information there that's useful, so it's good to read it sometimes. Okay, so let's mark what we know in orange. So we know this, and we can see it's not a right angle, right? Because they gave us the angle right there. We know this. And they want to know this. Okay. All right, so basically, if we could figure out, if we could solve this triangle here completely, then it would be easy to figure out h and 7.8, right? Because if we knew the length of this side, then we could make a triangle out of that, and if we knew the angles. So let's just concentrate on the triangle PQR first and try to figure out what the other side is. We can try to figure out what the other angles are. We're going to need that information. Okay, so first, and it's going to take us through it. Look at that. They're telling us, hey, find PR first. Okay, so obviously we don't have any angle and opposite side pairs, so we're not going to be using law of cosines. We're going to be using, or law of sines. We're going to be using law of cosines, and um, our cosine angles are going to be Q, R, and P. So we'll just write it out first in the regular form. A squared equals B squared plus C squared minus 2BC cosine of A. And all of our A's are going to turn into Q's because that's our angle that we have, right? The angle that we know is Q, so we need to use that Q. The other ones can be R or an S, right? R and, oh, I'm sorry, R and P. So side R, side P, okay. And so Q squared equals, and then R squared would be 8.2 squared, and P squared would be 12.3 squared, and then 2PR would be 2 times 8.2 times R, which is 12.3. Cosine of Q is cosine of 100. Cosine of 100. Okay. And then we can just put this in the calculator. Cosine of 100, negative 0.174. 2 times 8.2 times 12.3 is 202. Okay, and 8.2 squared is equal to 1721. 12.3 squared, 151. So we have 1721 plus 151 minus and then we have 202 times 202 times 0.174, 35.1. And we're adding that because the two negatives make a positive. So 1 plus 35.1. Okay. Oops. $1907. That's Q squared. So what's Q? Q is going to be 43.7. Okay, so Q is actually PR. So they said find PR first, and that's that. Okay. Now it says find the size of the angle PRQ. PRQ. So PRQ is actually this angle R here. Okay. So now that we know all three sides plus an angle, now we can find the angle R using law of sines. So now we're going to say, okay, small r over sine of big R is equal to small q over sine of big Q. And so we can flip this over too. Okay, so instead of writing it like that, let's flip it over. It's the same thing. We could have sine of big R divided by small r is equal to the sine of big Q divided by small q. Okay, so, and small r is equal to, that's small r, right? And this is small p. Okay, so small r is going to be 8.2. Small q, we just found, it's 43.7. Something's wrong. 43.7 is way too big for PR, isn't it? Look at that. That can't be 43. I must have done this addition wrong. Let's try that again. Oh, look at that. 8.2 squared can't be 1721. It's 67.2. Okay, so it's 67.2 plus 151 plus 35.1, 253 here, square root, 15.9. Okay, that's better. I didn't go back and check to see if it made sense. So this is going to be 15.9. Okay. Sine of Q, well, Q is 100 degrees. Let's take the sine of Q. We get 0.985. 0.985. So we take 0.985, we divide it by 15.9, and then we're going to multiply it times 8.2. And so the sine of R is going to be equal to 0.508. Okay? And then we can take the inverse sine of that to find R. It's 30.5 degrees. Okay, so that is the answer to part B. And then C, C, what they want us to do is, they want us to take this new triangle, which is this triangle here. They want us to solve this triangle. So we got the diagonal, which we already know is 15.9. And the vertical height, we don't know yet. And then some of these angles we do know, right? Because we know that angle R is 30.5. And we know the angle Q is 100. So we can figure out angle P, but just by subtracting both of those from 180. So we go 180 minus 100, which would be 80. And then we subtract off angle R, which is 30.5, and we're left with 49.5 for angle P. So that angle is 49.5. Now, what about this angle here? That's the complementary angle. So like it would be 90 degrees minus that. So we have 40.5 for this one. 40.5 degrees. Okay? All right, and so we know this, and we know this, and we want to know that. So what trig relationship should we use? It's opposite over hypotenuse, that's sine. So the sine of 40.5 is equal to, and then we could put here x, x divided by 15.9. Okay? Sine of 40. Sine of 40.5. 0.649. So 0.649 equals x over 15.9. So x is equal to 0.649 times 15.9. So x is equal to 10.3. Okay, so the whole thing is 10.3. And this part of it here is 7.8. So what's h? So that would be 10.3 minus 7.8. And so what's left is h equals 2.5. Okay, so the answer here is 2.5. All right. Now it says here, if you know one side of the triangle, the base b, and the corresponding height, you can calculate the area of the triangle using the formula 1/2 base times height. Okay. Now, if you do not know the height, you can still calculate the area of the triangle just from two of the sides and the included angle. Okay, so let's see. So what they're saying is, hey, you don't know height here, but you do know A, and you know B, and you know the sine of that angle there, or you know that angle there. Okay, and then you can figure out the area anyway. Okay. This is actually related to law of sines, but we won't go into the derivation for this class. Okay, but you can see how when you have a non-right triangle, you can draw a height line through the non-right triangle, and then and basically when you figure out what this height is, you'll figure out that it involves the sine of an angle. Okay, so that's why it ends up being 1/2 AB sine C. Okay, let's try a few. This is probably the easiest thing that we're going to do in this chapter, so you can relax a little bit now. So when you have two sides and they include an angle, and they ask you for the area, you know which formula you're going to use. You're going to use that one. Okay, so the area is going to be equal to 1/2 AB sine of angle C. And angle C, of course, is 82 degrees. And AB, of course, is the other two sides, so 7 and 12. And then times 1/2, right? So 1/2 times 7 times 12 would be 42 times the sine of 82. Sine of 82 is 0.99. So 42 times 0.99 is very close to 42. It's going to be 41.59, 41.6. Okay? That'll be the area of that triangle. Does that sound reasonable? Yeah. If you take 7 times 12, you get like a number like 70, so it should be about half that. Okay. So that's it for page 12.